You participated in a presentation maybe a week or more ago where Kristen Neath, our Canadian National Sales Manager, presented information on various methods of controlling one of the most common outdoor noise control issues or noise issues is air-cooled chillers. And she presented various ways of solving that noise. What we thought we would do on this next presentation is drill down a little deeper on a specific noise control. We call it our Ultimate Series noise control for an air-cooled chiller. Not always needed, only needed when you need extreme noise control. And probably we see it about 30–35% of the time where this full Ultimate system is needed. I'll introduce myself for those of you that don't know me. My name is John Sofra. I'm the North American Market Manager for the Commercial Airflow, Industrial, and Environmental Markets at Kinetics. This particular topic is about the environmental market or outdoor noise control. I've been with Kinetics for about 18 years, but in the airflow and acoustics business for about 30 years. I wanted to start this particular discussion on an actual application we had on the east coast of North Carolina. I call it outdoor chiller noise block barrier wall system. Noise block is Kinetics' trade name. And I call it that, title it, but below that, notice I write typical school, which this was, it was a middle school. And then I put in parentheses, new or retrofit in question mark, with a question mark after it. And the reason I write that is, of course, it was new construction, but could you consider it retrofit? I think a retrofit is something after the fact, unplanned. And the reason I say this is kind of new / retrofit is because in the 11th and a half hour, you can see I have highlighted here an equipment yard over in a corner at the end of that arrow. And in the 11th and a half hour, they couldn't get their final sign off on the site because there was an air-cooled chiller located in that equipment yard that was making too much noise above and beyond what was allowable on site. And it also was affecting not just getting the permit, but this was also 11th and a half hour. This school needed to get the permit because school was going to open in another 4 weeks for the next school year. So I say new or retrofit, very common, 11th and a half hour solution. If you look at the site overview, you'll see the equipment yard. This is a picture taken before our noise control solution. And you can see the air-cooled chiller in the equipment yard. I highlighted it there in red, the circle. And the air-cooled chiller close to the building. Now this walkway that you see coming from the driveway or drive-through, this walkway is one of the main rear entrances to the school. And although it wasn't the main front entrance, there still was a lot of deliveries, both materials and food through this back entrance. And most of the school teachers would come in through this back entrance. And right at the bottom here, right as you go into the school, there's an opening to that equipment yard. And they were exceeding the noise level there of actually 85 dBA at this particular spot when that chiller was running 100% load. So those were the things we needed to be concerned with. They weren't getting their permit. Noise control attempt. Initially, many people assume that, hey, we'll just go in and wrap the compressors with a mass-loaded vinyl jacket, custom fit, and that's all that's needed. And no problem. A lot of chiller manufacturers offer that. It's a great product, but it's only part of the solution. It very seldom solves the entire problem by just controlling the noise of those compressors. Why? Because it's a system noise. And for those of you that participated last month, the system noise, to remind you, is twofold. It's both the screw compressors at the bottom of the unit, radiating mid to high frequency whining noise, and then the upblast fans generating the mid to low frequency noise. And you have to take it all into account. Addressing one doesn't always, will not always solve the problem, and very seldom does it. When we approach one of these opportunities, usually meeting with an acoustical consultant, the owner, our Kinetics representative, maybe a local general contractor, or mechanical or sheet metal contractor, we'll all meet together, all right? And there are things that we want to look at from a Kinetics standpoint, from a design standpoint. The acoustical consultant has looked, maybe done site surveys, has some ideas on what they want to do, but they know they can come to Kinetics to help them solve the issue more focused. And so when we look at this, the first thing we do, our Kinetics reps or Kinetics internal team, we'll come in and we'll say, is there a noise ordinance? That's the first thing we wanted to look at. Knowing nothing about this job or this project and opportunity, is there a noise ordinance involved? Was the problem at the property line and the neighbors were complaining? In this case, they weren't. It was even closer to the site than a property line. It was actually a walkway 5 feet away from the opening of the equipment yard. So the location of the chiller with respect to critical areas, and that's what we were looking at, was, okay, the critical area is 5 feet away, it's this walkway. Structural issues, we want to take a look at Kinetics because Kinetics specializes also in seismic restraint, wind restraint, and vibration isolation and structure-borne noise. We have structural engineers on staff. And so when we design any system, a noise control system of this nature and many other natures, whether indoor or outdoor, we have that backing internal. And the questions they're going to always ask us is, the first one is, what does the site look like? Is the equipment, in this case air-cooled chiller, is it on grade or is it up on a roof? And it's important for us to know because if it's up on a roof and based on the local IBC code, we will have different requirements to restrain or design our structural supports. So these are very important. This particular job was on the East Coast, of course, the coastline of North Carolina. So we had to take a look at the IBC code, hurricane force winds and things like that. And also the nice thing was it was on grade, so that was good. Then materials of construction, we wanted to look at, is it a coastal application? We have to look at different materials for coastal. Do they want them powder coated finish? And one thing I put in there, which is part of the code, of course, is local electric code, because in the end, what you'll find is some of these solutions, in this particular one, we have to shoehorn in. We need a lot of noise control. We have to shoehorn in, and these clearances that maybe the air-cooled chiller manufacturer will recommend or we'll have to encroach upon those. But the one thing we can encroach upon is the electric code, the clearance between the equipment and a solid surface wall. So those are important things to take into account. If you look at environmental surroundings, there's going to be reflections all over. So the acoustical consultant, as they look at these applications, they're going to once again want to know these site conditions, the environmental conditions or surroundings. And I wanted to show you a few things to think of. If the source here on the left is an air-cooled chiller and you have a barrier wall, you can see the barrier wall's up just a certain length. But looking at a plan view, you have to be careful of noise flanking around this wall. You may direct line of sight from the receiver to the source. Hey, I can't see the source, but oh my goodness, there's these reflective items in the area that can flank noise around and basically short circuit your noise control. So an acoustical consultant will be looking at this. Another thing is the up and over noise. So of course, if you're a barrier wall, you're always looking at an up and over noise. And the closer the receiver is to the barrier wall, they may be in this shadow zone. It's like an umbrella, a little shadow zone, protecting them from the reflection, and the noise reflects over them and they can't hear it as much. It helps for attenuation of the wall. But as the receiver gets further away, if there's trees, and in this case, there actually was some very tall trees in the area, there's a lot of reflection that can come off of those trees. And that's important to take into account. Acoustical consultant also looks at noise reflecting over a barrier if there's a building close by. So we may want to use some acoustic products on that building, absorption products, to absorb that reflective noise off the building and up over, all degrading the normal performance of your wall. So you have the acoustical consultant will take all that into account. In our application, we have a wonderful situation where the receiver is 5 feet from where you can see I have all my arrows, and you see in that concrete equipment yard, you're going to find there's a lot of reflective, it's cinder block, there's a lot of reflective surfaces, and it's actually magnifying the sound energy and the noise that the chiller's making. If the chiller was sitting in the middle of a parking lot somewhere and you were 50 feet away and there were none of these reflective surfaces, it would be of a certain sound level once it reaches you in sound pressure. However, in this case, it's actually going to be louder because of the reflectivity of the walls. And as we look here, the walkway was right across where the receiver is, parallel to the green line of the cinder block there by the arrows. And those are things we need to be concerned about. The receiver, usually an acoustical consultant will take a height above grade. Like the average person walking by might have a 5'5" ear height. And so they'll say the resultant noise level at before and after noise control is this, and at a certain height, maybe 5'5". Or people like me, they might say my average ear height is 5'2". So, those are things that the acoustical consultant will qualify in their analysis. When we look at this, we need required chiller information. So the first thing Kinetics team and representatives are going to ask you is, hey, we can look at that chiller, but we need a couple of things. We need a schematic, a general arrangement drawing of the site, but also of the chiller. We want the length, width, and height of that chiller given by the manufacturer's cut sheet. We want also to look at their guidelines, installation guidelines for clear airflow path. We don't want to control any recircs, but we'd like to see what the ideal situation is, because we're going to have to prove and show clearly to the air-cooled chiller manufacturer that we can encroach upon these clear airflow path clearances, and it'll still operate under design loads or as designed. We need the airflow rate. We want to know how many prop fans there are, how much total airflow in cubic feet per minute there is. And then we also want the sound power levels. You'll see a chiller manufacturer will have a chiller data sheet with sound power levels for each of the 8 octave bands. 1-to-1 octave bands fine, 63 hertz, 125, 250, all the way up to 8,000 hertz. That's perfect. That's what we need. Loading conditions, or whether we need, or we'll ask the acoustical consultant too, to say, okay, if you took readings in the field at maybe various loading conditions, 25, 50, or 100% loading of the unit, let's look at how those compare to the actual published data from the manufacturer. It's not that the manufacturer's data is wrong. It's not. It's just that the manufacturer's data is under ideal laboratory conditions. You don't have that. You have field conditions. So the acoustical consultant usually will take readings, and then we'll use both, take the highest in each octave band, and that'll be our design spectrum for our noise control. Now, the things that Kinetics offers, Kinetics reps, Kinetics environmental team offers is, for every job, we will put together a custom submittal drawing. And for every job, there'll be a piece-marked list of bill of material, all the pieces and parts, and a piece-marked installation drawing. It's like putting up an erector set. We've had a lot of contractors look at these. Since Kinetics doesn't do install, our reps will either organize it, or a mechanical or sheet metal or general contractor will do it. And if they've never done it before, they love it when they see, oh my God, it's all piece marked. It's like an erector set. This is perfect. All of our structural steel design is per the locally adopted IBC code. PE stamped calculations by a structural engineer. I don't know where that letter D came from there. I'll have to delete that. Bolt together design based on cast in place anchors. So the whole system, no field welding will be required, and we'll talk about this later on, but the whole system will be delivered, pre-drilled holes, base plate to column welded assemblies, backer angles, bolts, nuts, washers. The only thing that has to be at the site is the footings and cast in place anchors. If somebody says we're not going to do cast in place anchors because it's a retrofit application and we already have a foundation, then we can work with them on that. Our structural engineers will work with them on that. Kinetics, of course, manufactures the panels, these pergola baffles. You're going to see acoustic louvers, acoustic doors, and we also offer factory powder coated finishes. So we'll talk about that as well. Materials of construction. Most often, the best, most cost-effective and durable material is a galvanized sheet steel type G90. G90 is the coating thickness. Years back, they used to use G60, which has a thinner coating. You want G90, and that's pretty much what everybody uses these days, but it's always good for you to question what they're using. Alternatives, though, could be aluminum sheet steel, or aluminum sheet, or stainless steel 304 and 316. A lot of cases in wastewater treatment facilities and plants will use the 304 and 316 stainless. Steel panels are particularly suitable for mechanical equipment barriers, and the reason is because there's always these last minute penetrations that you have to cut into the wall for piping, conduit, whatever, things that you really can't locate. We typically say anything less than 6-inch diameter or 6-inch notch, we leave for field cutting. And it's nice because when you do field cut with a drill, a sawzall, things like that, and then safe off with trim we send, it does not diminish the structural integrity of the product. Different powder coatings we use as standard at Kinetics. We're not a painter, we're not a fabricator of powder, but the two powders that we tend to really like, they're very forgiving, they are very durable, and they're very cost effective. And one is by Tiger Drylac, a series 38 and 49. And then another one is Sherwin-Williams Powdura. We use them interchangeably. And then we have a selection of standard colors within those groupings or types of brands of paint. And then we also have options for color matching. Powder coating opposed to wet paint, though, is our typical go-to. However, for some applications where wet paint might be necessary, or because of the color or formulation, or maybe you want metallic, different designs, where we might have to go to wet paint, we will use a wet paint that is equivalent durability to these powders. One of the products that we use for our wall systems is our double wall panel. Noise block is our trade name. You've seen it on a few of the screens. That's a Kinetics trade name for many years now. Just reminding everybody, Kinetics has been around since 1958, and that's been a great name, noise block. Both absorbs and blocks sound. Also internal sound absorbing media, suitable for wet, dry, freeze, thaw cycling. We do not have to bag our insulation media within our barrier wall panels that are outside. Some people say, don't you have to bag it and worry about rain and moisture? This product that we use has great acoustic abilities, but it's like a wick away type product. It doesn't hold moisture, it dries quickly, and it's not affected. We had a project once that we went out to a site and we saw a project. It wasn't on one of our walls, but we saw a project where somebody had bagged this fill, and it was in upstate New York. It was cold, and what happened was over time, this wall had been up there. Over time, moisture was created or collected in the bagged fill, in the bagging, due to just minute pinholes and things that happen over time, and then it froze. What happens when water freezes? It expands. And what happened, you could see at the bottom of all these panels on the inside perf, the perf had pulled away from the skin, had pulled away from the panel. So, that was a great example on why Kinetics doesn't bag this and doesn't need to. And we worked with our raw material suppliers to get beyond that. We have various thicknesses, although 4-inch thick is a very good structural modulus that keeps this. It's a good panel. It's the majority of panels we make 4-inch thick, but we do make panels from 2-inch thick all the way up to 12-inch thick, depending on the application. Our most common barrier wall panels in these chiller designs and solutions we present here. We have many other configurations of construction and types and thicknesses, but these are the most common. We really like to go to a 16 gauge solid 22 perf. And the reason is the 16 gauge solid, when sun hits that metal and you get some thermal expansion and you get the cycling of the heat and the cold, it doesn't show waviness. And I think that's very important from the aesthetic standpoint. So we really look at 16 gauge. Sometimes when we go to stainless, because it is a harder material, we would go to 18 gauge at wastewater treatment facilities for the solid skin of this panel. Panel installation, it's a beautiful thing. It's very simple. Like I said, everything comes out as freestanding, complete bolt together structural steel components. Base plate to column welded assemblies. And the nice thing here is I say quiet installation. And the reason that is Kinetics has done a lot of oil and gas over the years, wall systems over the years for midstream compression. And also, though, this applies to just inner city where they have to put this stuff up. Because it's bolt together, no field welding, very little, the only noise you really have is a lift or a crane. They can work at all hours of the day because it's a very quiet installation. And once again, it's all bolt together, no field welding required. Another product within the solution you're going to see are acoustic louvers. Kinetics has many acoustic louvers. They're all independently tested per applicable ASTM standards, and so were the noise block panels. There's internal sound absorbing media. Once again, wet, dry, freeze, thaw, cycling, it's fine. You will see what you're looking at on the right there is the solid surfaces of the acoustic louvers. Underneath each air passage is a perforated sheet. And so the noise, as it propagates through the air passages, some of that sound energy penetrates the perforations and then gets absorbed into the media fill. Once again, available in many different constructions, materials, and they're available in thicknesses from 4 to 24-inch thick of various percent open areas. And the importance here is we have enough product that depending on the application, remember, we don't want to affect the performance of that air-cooled chiller. We can tune the products that we offer so we can get the right minimal, extreme minimal back pressure, but get the acoustics we need. If you were to look on the Kinetics website, it kind of shows you a comparison here of the different types of louvers, acoustic louvers. We have a KCAC on the left, and that's our no through line of sight, as you would expect. And you can see in the graph, we have octave band on the horizontal axis, and on the y-axis, we have decibels. So that's noise reduction, not transmission loss, but noise reduction per frequency, typical for that type of acoustic louver. Now, it would vary, of course, though, on thickness. And what it doesn't say here is these are all based on 12-inch thickness. So that graph is all on 12-inch thickness, even though we provide thicker acoustic louvers. So you have a common comparison baseline. If you look at the KCPL, the middle one, that one is the green curve, or at least green on my screen, and it shows the transmission loss there. And then the KCAL, which is our most industrial louver, it shows your noise reduction there. If you look at the difference, you may say, well, why do I have a KCPL and a KCAL? They look the same. They really don't. The KCPL acoustic louver was developed to look more like a weather louver, more architectural pleasing, more blades. Where you look at the KCAL, it's much more robust, industrious looking. So the reason we came up with the KCPL, other than having additional spectrum noise reduction shapes and pressure drops, was also for the aesthetics. Now the next thing is the noise block pergola. This is a great product. It's made of, you can see in the right there, it's made of our noise block panels, but instead of being solid and perf one side and solid the other, they're perforated both sides with a solid frame of sheet metal. So it's a panel with perf both sides. They work like silencer baffles. And we model this using computational fluid dynamics and finite element equations that we have in-house, that we can balance both the height of those, the thickness, and the spacing, which will affect the open area, and in the end affect the overall back pressure, which needs to be extremely low. We don't want to affect the performance of the chiller. So we balance the total chiller airflow, pressure loss, and required noise reduction. We do that in-house with our algorithms, helping the acoustical consultant model this. Internal sound absorbing media, once again, wet, dry, freeze, thaw, no bagging, you're in good shape there. Different materials and various thicknesses, depths, and percent open areas. So that's our pergola. If we look at this application and really dig in now and look at what's going on, we got about 5 minutes. I always run from noon to 12:30. I take a little extra time, but we call it our ultimate series. It's not always needed, but what we need to do is, you can see the air-cooled chiller, we have to encroach a little more, but within electric code, a little more on the air-cooled chiller than the manufacturer would really recommend or want. However, Kinetics can do, well, before we get to that, we'll give you some size feel here. This is 16 feet wide, 13 foot tall, okay, is the actual system. You can kind of see our noise block double door, heavy duty hinges, seals, panic passage hardware. I mean, that's a monstrous door. That's a 4-inch thick monster door, but it is what you need to keep the transmission loss equal to the walls. If we look here, we have the door, we have our noise block panels, and then we have our acoustic louvers. These are 12-inch thick louvers. Another view here, kind of sees inside the. Now, we were going to align, the acoustical consultant had looked at lining the walls of this air-cooled chiller, of this equipment yard to control the noise. The problem is the design could only get about 8 to 10 dBA, and we needed more. We needed a lot more. Okay, we needed about 16 dBA reduction. So that's why we had to go to this system. Here's another picture from another area. The foundation's done by others. So Kinetics designs everything from base plate upward. And so what we mean is starting at that red line elevation, we design everything base plate upward. We give reaction forces at the base plate so the engineer of record designing this pad and of the site can take those reaction forces and design the foundation and foundation anchors. Shows you the inside where the noise block panels are sandwiched in the webs of the columns and all bolt together. You see the pergola up top and the acoustic louvers. And the side of the acoustic louver you're looking at is all perforated metal. From the outside, it's all solid metal, you can see here. Typical field verified performance, and this is the neat thing because we have independent testing, we have in-house modeling, and then working with acoustical consultants, it's so nice to get their field data after installation. And what we looked at was when you're standing by the walls and you're 10 feet away from a wall, 5'5" above grade, you looked at anywhere when you walked around that, and of course there was some reflection issues because our system was closer to the cinder block wall in some areas than others, and we ranged from an 18 to 23 dBA reduction. On the top, holding a microphone 10 feet above the top and doing an array across the top of the pergola outside the enclosure, we were seeing an 8 to 10 dBA reduction. And across the system, upstream of the skirted wall louvers and downstream of the parallel baffles was only 1/10 of an inch water gauge pressure loss. Very minimal. That's key. If you can do that, the equipment can breathe properly. You won't void warranties. You'll work with the chiller manufacturer, and the owner's going to be extremely happy between the acoustical consultants working with Kinetics, our rep, the installers, and the chiller manufacturer. Now, just to show you a few more, here's one to give you an example. This is at a hospital, another Ultimate Series, same products. And then here and there, you actually have a grouping of dry coolers and AC units. This is from inside that same enclosure. So I thank you for joining us. We're going to have many more next month. We're going to present this 2 more times this month. Next month, we're going to have the basics of silencers, ventilation silencers, how they can be used, what affects their performance. Kristen Neath will be presenting that. So please be on the lookout for an invite. Once again, our market web page is listed here, product web page, rep locator. We have a great web locator now. It was always good, but now we have one you just point and shoot on a map and find your rep. If you're in the US, send us an email at environmentalsales@kineticsnoise.com. For our Canadian family and friends, canadiansales@kineticsnoise.com, and anywhere else in the world, because we are worldwide with agents, please contact your usual, because I know you've already worked with both teams. So thank you very much for your time.